Now, are odds and probability the same thing? Odds is a way to look at the probability of something, but they're not the same. Now, let's say in tennis today, Elijah has 5-2 odds of winning. What does that mean? What do odds mean? Well, uh, he has 5 chances of winning and 2 chances of losing. Okay? This is odds. Where probability, how many total chances are there here? 7. So he has a 5 in 7 chance of winning and a 2 in 7 chance of losing. Okay? So odds and probability are different. You can find one from the other, but odds and probability are different. So most of this chapter is going to deal with probabilities. So you can't think odds, you got to think probability, but every once in a while they'll throw odds in there and you got to understand they're different. An outcome as a result of some situation or experiment. Like, I'll talk about rolling a die all the time in here, this chapter. If you roll a die, how many sides are there in a die? In a die, like a pair of dice, and one of them is a die. 6 sides. So if you roll it, you've got 6 different outcomes: a 1, a 2, a 3, a 4, a 5, and a 6. Okay? Those are outcomes. An event is a single outcome or group of any outcome. The sample space is a set of all possible outcomes. Okay, so let's look at the sample space here once. Okay, I'll show you what a sample space looks like. Let's say we toss a coin twice. The first time, it's either heads or tails. The second time, it's either heads or tails, right? So the coins could have gone heads, then heads again, or heads, then tails, or else tails, then heads, or then tails, then tails. That's a sample space. These are all the possible outcomes: heads, 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 tails, tails, heads, tails, tails. Okay? Now, probability that 5 out of 7 that Eli would win today. Okay? Eli doesn't have a 7 out of 5 chance of winning, because 7 out of 5 would be more than 100%. He can't have more than 100% chance of winning. Okay? He might think of himself as giving 110% to his tennis, but he can't really give 110% to his tennis. He can only give 100%. Probability, you can only get up to 100%. You can't go over 100%. So it's between 0 and 1. Experimental probability is actually doing something, like rolling a die. Okay? If I roll a die 6 times, is one number going to happen to come up more than once? Probably. Okay? The probability is, the theoretical probability is each number should occur only once if I roll it 6 times. Okay? I should roll a 1, then probably a 2, then a 3, and so on. But experimental, you'll have, each number come up, one number might come up twice and one number might not come up at all. Now, if you keep rolling it 10,000, 30,000 times, by the law of averages, each number will likely equal out. But if you do it just a few times, they'll not equal out. Okay? Theoretical probability is the math behind it. That's the math probability, where each number should come up once. And the complementing event is what doesn't happen. So if we have a 70% chance of rain tomorrow, what's the complement of that? It's a 30% chance that it won't rain tomorrow. So looking at this class, there's boys and girls. There's 1, 2, 3, 4, 5, 6, 7, 8 girls in here. And there's 1, 2, 3, 4, 5, 6, 7, 8 boys. Jeez. Wait, did I count? Kiana was hiding back there. So 9 girls and 8 boys. Good. Because I didn't want it 8 and 8. That was too easy. So the probability that, let's say, a girl gets her assignment done first would be 9 out of the 17 people in here. The probability of boy is 8 out of 17. Okay? All right. Let's go and look at the problems. A spinner. Spinner problems are by far the easiest problems that you'll see in here. Okay? If you spin it, what's the probability of getting an even number? Well, how many even numbers are on there? 4. How many total numbers? 4 out of 8 reduces to? Half the time you should get an even number. Does that mean you'll get an even number half the time? No. Experimentally, you probably won't get an even number half the time. But if you spin it 30,000 times, it'll get awful close to 1/2. What's the probability of spinning a number not less than 3? How many numbers not less than 3 are there? Is 3 not less than 3? Now think about it. Okay? Is 1 not less than 3? 1 is less than 3. Is 2 not less than 3? 2 is less than 3. Is 3 not less than 3? 3 is equal to 3. So is 3 less than 3? No, but 3 is equal to 3. So numbers not less than 3 are 4, 5, 6, 7, and 8, right? So it's a 5 out of 8 chance. Or is it a 6 out of 8? Now let me think. Now I got confused on this one. Not less than 3. 1 and 2 are the only numbers less than 3, right? 3 is not less than 3. All right. Is it 3, 4, 5, 6, 7, and 8? Or 5? Now I am totally confused. Not less than 3. Because the numbers less than 3 are 1 and 2. Not less than 3 are 3, 4, 5, 6. Yeah, I think there's 6 out of the 8. I'm going to go look at the answer. It's 3 out of 4. You looked at the answer? Okay, I'm glad you're smart, Nick. Because it is 3 out of 4. Because, yeah, 3 is not less than 3. It's equal to 3. Okay. Why we use probability? So then we can make mathematical determinations that are too hard to test. Out of 80 workers surveyed, 13 walked to work. What's the experimental probability? Well, 13 out of 80 walk to work. What's somebody calculator? What's 13 divided by 80? No. 0.16 repeating or 0.16? 0.1625. Yep. Leave all the decimals in there. All right. So 0.1625% of the people walk to work, basically. Okay? So about how many workers walk to work if you have 4,100 workers? Well, you take this times your 4,100 workers. And about how many walk to work? And round to the nearest 10, it says. If there's 666, it would round up to 670 people walk to work. Okay, because you're rounding to the nearest 10. Okay. Now, let's say you have Scrabble tiles spelling out Georgia, and you throw them all in a bag. What's the probability of picking out an A out of there? Well, there's 1, 2, 3, 4, 5, 6, 7 letters in Georgia. What's the probability of picking out an A? 1 out of 7. What's the probability of picking out a G? 2 out of 7. Okay. All right. Sample space. Now, this takes a little while sometimes. Sample space of flipping a coin. You either got heads or tails, which results in a heads or tails, which results in a heads or tails, or a heads or tails, or a heads or tails, or heads or tails. So you could go heads, heads, heads 3 times in a row, or heads, heads, tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, tails, tails, tails. So, how many different outcomes are there? 8 different outcomes. 1, 2, 3, 4, 5, 6, 7, 8. 8 different outcomes. Okay, tennis guys, you can go. So that's a sample space. So you just type all these down with a comma in between. So heads, 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 comma, heads, heads, tails, comma, and so on. What's the probability of tossing at least 2 heads? Well, this one has at least 2 heads. So does this one, and this one, and this one. So 4 out of 8, which is half the time, you'll toss 2 heads. Okay. I think you can get the CDs one. You just add them all up and pick it out. The rain tomorrow, not rain tomorrow, we already did. This one was the workers walking to work. It's the same type of thing. What? So if 9 out of 525 calculators are defective, you turn that into a decimal. So somebody take 9 divided by 525. 0.017 exactly. Something like that, right? So then what you do is take this number times the 17,000 and round to the nearest whole number. You're going to have 491 calculators out of 17,000 produced be defective, which isn't very good. Well, I don't know. I can't hear. You guys talk with masks on and I can't understand you. All right, 291. All right. And the last one. There's 3 redheads out of 60 people. So that's a 1 out of 20 probability that they're going to have red hair. Oh, that's not the last one. Here's the last one. What's the probability of not being in trade school? Okay, these add up to 100. Going to trade school is 16. So how many are not in trade school out of the 100? 84 out of 100, which if you reduce down is 21 out of 25, right? Okay, so there we are. So you have 10 problems. Let me put it out there for you.